Those of you who've been here for previous presentations will know that this is one of our oldest projects in the real-time communications lab. And the students here have created a automated test device based on the algorithm that has been constructed in a draft at the IETF. Myself and two of my colleagues wrote this. So this is to enable a very particular type of performance testing on a SIP proxy. I'm sorry for this. So further away? Okay. So the students have created an automated test procedure for this, which is going to open up tremendous opportunities for us. And they're going to describe to you what they did and how they did it. And they're actually going to give you a little video of it. So I'm going to turn it over to them.
Hi everyone, how you doing today? My name is Oluseyi Solomon Awotaya. With me on this project is Hato Chloe and Yuechin Jiang. They've been so wonderful. Can you just put your hands together for them while we were working together? We'll be talking about a SIP performance benchmark. We have this project goals while we embarked on this project. The first one is to measure the maximum SIP throughput with no errors that a SIP proxy can support. And basically, the second step is to write a script to run this test automatically, then analyze the results for each scenarios, which will be discussed to us much later after now. And we have the tasks and milestones while we embarked on this project is to understand the SIP benchmarking methodology and the SIP benchmarking terminology. Becoming familiar with the SIP tool, SIPp tool, and IETF algorithms. And also to write a bash script to automate tests, run all the scenarios, and analyze the results as well. This project, like Professor said, it's been in existence for a while, but we worked on what result they were able to achieve in the time past, and the reports that was made available to us through the IETF data tracker and through the RTC lab for us to achieve the best result that we had. Basically, I'm going to talk about the test bed of the architecture of the project. We did not put Wireshark on the UAC. The UAC is a user agent client, and we didn't put it on the UAS, which is the user agent server, and we did not put it on any of the proxies, which is the Asterisk. And we call this in this project the DUT, D-U-T, which is device under test. So we actually did this for us not to have interference with the CPU memory usage of the computers at the particular time of the test, for us to be able to achieve the best results that we can have at each of the tests that we undergo. So we don't have to have low outputs or low results, so we can know what we're testing and what we're trying to achieve. And we put the Wireshark on the port 21, which is what we use to do the monitor part, for us to run the Wireshark separately and without interference with the user agent clients and the servers and the device on the test. This is the configuration of the servers we made use of. All of them runs on Sense OS 6.6. And then, as you can see, the processor is pretty old, Intel Core 2 6420. And this was what we made use of, and it's really worked for us. And all the servers run on 4 gig memory, which helped us out too. I will hand it over to my colleague to talk about the scripting and other part of it.
Is it good? Yep. So the very main goal of our project was to design and write a script with bash. Before that, Before that, you need to know that we use SIPp. So Bart told you a bit about SIPp. It's a tool. It's a tool on Linux. It's a client-server tool. So you can see client and server tool. You can tell SIPp to pass through a proxy, Asterisk or Chameleon. You will see that with Yuchin after. So the main goal of our project was to find the largest value of a SIP session write, also called call write or breaking point, which the SUT system under test can process without any error or without failed call. So this script is based on IETF algorithm, as said earlier. So each time you are running the script or the SIP tool, you have a log file on your computer, and you can see so many values. The one we are interested in is the successful call and failed call. In this one, you can see there is 0 failed call and 3,000 successful call. Each time we are looking for the value of the failed call to do another testing. So we made a little schema. I will try to be the more clear as possible. When you start the script, you start with a value of, for example, in that case, 100 call rate, which is 100 calls per second, sent from the client to the server. If there is no failure, we are raising this call rate, in that case, to 200, so we multiply by 2. We also save the left limit, which is the minimum value where you have a breaking a call rate without any failed call. In that case, there is also no failed call in 200 for 200 call for a call rate of 200. So we are raising to 400. At 400 calls per second, we have a failure. So the script is going to decrease the call rate, in that case 300, and now we have a write limit, which is the maximum call rate where there is a failure. So now the script is going to bounce back and forth between the two limits to find the middle value for the breaking point. So I'm going fast on this one. There is a failure at 300, so the limit 2 is not 300. We are going to decrease the call rate to 250. No failure at 250, so we are increasing to 275. Failure at 275, so we are going to 263. And in the end, we find a breaking point of 269 calls per second. So you are going to say how the script knows when to stop the processing. It's called the granularity, which is a very difficult word to pronounce. Also called the accuracy. And I will show you a video to explain you that. So you can see on the left, this is the client, and on the right, this is the server. Every time you launch the server first, and then the client. So if you look, yeah, it's very fast. If you look carefully, you can see that we put a 5, which is the granularity, 5. So the script is starting. You can see there, the call rate is 100. This is the first call rate we asked the script to go. The script is running, and you will see the log file. Up. You can see there is no failure. So now we are increasing the call rate. In that case, we are increasing the call rate by 50%. So we are now going to 150 calls per second. In that case too, there is no failure, so you will see it will increase to 225. Okay, so I'm going to advance. Okay, we increase the call rate to 337, And you can see there is a lot of retransmission and timeout. So in that case, you will see a failure. And more precisely, the number of failed calls, 23. So the script saves the limit of 337, the write limit, and is now going to decrease the call rate to 281. So I'm going to advance further. And the most important thing, so you need to remind the value of 316 in your head. Very important for the end. You can see there is a failure. And you can see finally the breaking point is 313. So the script is calculating the granularity by doing a subtraction between the last call rate you used, so it was 316, remember? And the last call rate with no failure was 309. If you are doing the subtraction between 316 and 309, it's 5, so it's equal to the granularity or accuracy. So the test is stopping. Of course, you can say, give me an accuracy of one call. This is the more precise value you will obtain. But it's very long in that case. So this script was made in Bash. It was very fun to do. And now you can use this script for any scenarios and on any proxies like Asterisk, Camelio, PBX server. We were talking about this earlier. We have different versions without RTP, without media, with media, and on different proxy. So with the script, you just, it's not the same. You just have to change some values in the file, and if you want to see the script entirely, it's on the poster, and we can send you the script because it's free. This is that. Yeah. So with this script, we were able to run a lot of scenarios, and we are going to be able to use this in the future and transmit the script to other students for the next semester and years.
So here you can see our test results are based on 4 scenarios. The first 2 about the no device under test with RTP and without RTP. And the third and fourth one is about we're using Asterisk as our SIP proxy with RTP and without RTP. And why we need to test the first and the second one without the device under test, because we need to know the maximum capacity of our test bed. Like if we get the maximum call rate based on these 2 tests, we can know we can't get any call rate above the result we get from the without the device under test. So here is the Wireshark trace we took. You can see there are 3 completed calls between the user agent client and the user agent server. It's without device under test and without RTP. And here is our analytic table. You can see we used the same call length 9 seconds as our comparison. And you can see we use granularity 1, 2, and 3 to show our breakpoint for this situation. If you want, why we use this call length? Because we want to compare the situation with RTP on the following situation. So here is the graph to describe the relation between the breakpoint and duration of test. You can see no matter what is the granularity we use, or we can have a lower breakpoint when our duration of test is longer. But if we raise the duration of test to like 10 minutes or 15 minutes, we can get the value of breakpoint to approach a constant number. This test is already done by previous student. And here is the So here is the trace of a Wireshark we took from the node.esRTP. And what's the difference between this trace with the previous one? You can see here is the RTP between these two user agents. And this is the table to analyze the situation with the previous one. Why we didn't put call length in this table? Because the call length is already set in the pickup file, and the 8 seconds is set by the duration time of sending RTP, and 1 second is set up to DTMF. Okay, so we also use the granularity 1, 2, and 3 to show our test results. And here is the graph to show the breakpoint and the duration of test. You can see there's almost the very close result when we use whatever the granularity is, and we whatever the duration of test we took. So we can get a conclusion that the granularity and the duration of test can't have influence on our result of test. So here is the comparison chart to compare the two scenarios, like node.esRTP and node.noRTP. The green is the situation for the breakpoint for the node.without RTP, and the blue is for node.with RTP. So you can see in this graph the value of breakpoint of node.without RTP is much higher than the value of breakpoint of node.esRTP. Why? Because we think if we sending the RTP, we will consume a lot resource of our computer. So that's caused this result very, 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 very large. Okay. So here is the trace for the yes.noRTP. We're using the asterisk as our proxy. And you can see the middle of the address is for our asterisk. And it is forward the signaling message from the user agent client to user agent server. And here is the table for comparison. And now it's the graph to describe the relation between the breakpoint and duration of test. No matter the granularity, yes, we got a lower breakpoint when we raised the duration of test, but you can see when the duration of test is 30 seconds and the duration of test is 90 seconds, we get a very close value of breakpoint. So we can have a conclusion like the value of breakpoint is approached to the constant number when we raise the duration of test like 10 minutes and 15 minutes. Here is the trace for yes.esRTP, and the difference is like the proxy forward handled RTP. When we set the parameters in the file to like carry invite equals no. Okay. Here is the table to show the results. And this graph is also describe the relation between the breakpoint and the duration of test. You can see the value of breakpoint is not influenced by the granularity and the duration of test. And this comparison chart can show us if we use RTP, the value of breakpoint is much lower than the situation without RTP. Why? Because If we send the RTP, we use a lot of resource of our computer, so that's the reason. And here is the situation to prove the first, to prove our previously said is like we can't get any result exceed the maximum capacity of our test bed. It's with RTP, but without that. Okay, so that's it.
All right, in conclusion, that was the confirmation of the last, we got the confirmation of the last year's results, and we know we made something ahead of that, and that is what you can see that we've displayed onto you. And we are looking at way forward about the projects. We're still looking at using new scenarios, and at the same time using new devices on the test, and to see the results we can achieve. Definitely the projects will continue through the years. And thank you for the time. Thank you for listening to us. Questions, please.
What was the break point if you let the test run much longer than 90 seconds?
Yeah, so the question was, what is the breakpoint if we are letting the test running for infinity? So we didn't do this test because it was already done last semester, but eventually you can go at this slide. Yeah. So yeah, let's talk about this example. Last semester, they reached a constant value. In fact, no zero call in the end. You know. Yeah.
Do you have any idea what that constant value was?
No. I'll be honest.
It's posted in on the website. That's a good question, and we'll make more of that public.
Yeah.
We keep a Google site where we look at the previous, we look at previous results, and their goal was to automate. So they did a lot of short things while they did the testing, and they did it well. But we did confirm that it doesn't go to zero. It actually it converges eventually to a non-zero value, pretty close to what they got.
Have you made the script available more broadly, say to the Asterisk developer community? If not, do you intend to? If so, have you seen people use it? What's the experience outside of that?
The question is about the script. Is the script available to anyone? So we want to make this available for anyone. We are just going to write our names in the script, and it will be available through a website. So you need to ask Carol for this, because I think she has a platform where she puts.
We're putting it up on the track.
Yes.
And I think we're going to make it public.
And it's a good idea to ask Asterisk developer.
So would you be publicizing it, say, in the Asterisk developers mailing lists and those kinds of things, or?
Why not? Yeah. Could be
If
nice.
people use it, that would be a good spot to do it.
Yes.
Great suggestion. Yeah.
Any other question?
We think it can be used, for example, at